Next, we will have a look at different plot types to plot distributions. And one popular plot here is the histogram. So the idea is that the data is split into small bins, and then for each bin it is counted how many data points fall into this category. So you can do a histogram with the geom histogram function. And for that, you only have to specify an x-axis. For example, here the sepal length, you don't have to define a y-axis because this is then a count value here. This is done by the geom histogram function. But what you can do is to color it. In this case here, you may want to use fill instead of color because it fills out the areas of these histograms. One thing to keep in mind is that you may have to choose the number of bins, which I choose here as 10, or the bin width manually to get a good result. As an alternative to histogram, you can also calculate density plots, for example, with geom density, which then draws a kernel density estimate, so basically a smoothed version of the histogram, which I use here again, just defining an x value and a fill value for the color, which then splits it up into 3 species here, and then reduce the alpha value a bit so I can see actually exactly where the distribution is for all of the 3 species. A different way to plot distributions are box plots. So in the box plots, the median and the quantiles are visible. So this bar here is the median and the edges of the boxes are the first and third quartile. And the length of the box is the so-called interquartile range. And then the viscous, so these lines here, go from the end of the box to at most 1.5 times the interquartile range. If there is no data point in this area, then it just goes to the last data point. And you can see here in this case, for the Virginica species, that there is an outlier. So everything that is more than 1.5 times the interquartile range from the median will then get plotted as an outlier. So for the box plots, you need x and y, but here in this case, x is not a numerical column, but a categorical column, like a factor. So in the default version, when you don't specify anything, it will then plot these 3 species here in alphabetical order. If you want to change that, you can't really do this within this ggplot code, but you need to change the level order in your dataset. And here you can see that color in terms of box plot means the outer color. So the color of the lines and the points. If you want to change the color of the area here in the box plot, which is white here, you need to use fill instead of color. And the function is simply called geom-box-plots to use for the box plots. So this is a good way to display some important sample statistics for the data distribution, like the median and the quartiles. An alternative and a bit like combination of a density plot and the box plot is the so-called violin plot, which works similar to a box plot. So you have to specify x and y, and you can specify a color or a fill. And then you can use the geom violin function, just like you use geom box plots. And you can decide here if you want to draw some quantiles. For example, here we choose the same that are plotted in the box plots. So the first quantile, the median, and the third quantile. And then you can see here a combination of some kind of box plots, but with also a density element here. So areas here where the plot is very small, you can see that there's not much data points, but here in the middle there are more data points. So this would allow you also to assess multimodal data, for example. And there are different scales that you can use. For example, each violin plot should have the same area, or the area should be based off the number of data points, or that all violin plots have the same maximum width. So these are different options here. So this also has some summary statistic, but emphasizes more the data distribution, like a density plot, for example. Now it's time for the next part of the exercises, so please have a look at the exercises 2.4 to 2.7.